Now moving forward to the exact syntax and stuff like that, let's go into deeper detail of what are different instructions this guy supports, MIPS processor supports. The very first one you will see is the unconditional branch level, and it is a pseudo instruction. That means MIPS doesn't support it. It only the assembler implement that. So this is almost like a jumping to a certain level, only with the restriction of this 16K limitation. We can max we can do a 16K jump forward and backward, that number of instruction with the branch. I believe with the jump it is more than the branch instruction can do. We'll double check, cross check when we come to this on the jump instruction. Okay, now these two, branch coprocessor false and coprocessor 2, this is more to deal with the interrupts. We haven't yet touched the interrupt and that concept yet, so you can just omit these two instructions for time being. Branch on equal, it is there, so the test for equality of these two register content and jump to the level depending on if it is true or not. Then we have the branch on greater than equal 0, BZEZ, which is like test this guy. If it is greater than equal 0, then jump into this level to this level. We have like branch on greater than equal 0 and link. So this is a little bit interesting instruction. What does it mean? What do we mean by the link? Okay, so let's explore. So let's say we have an instruction like this. Okay, some instruction. Then we have, let's say, this instruction BZEZAL $T0 to, let's say, some level 1, level 2. Okay, let's think for our own sake. Next instruction is at level 1. Under that we have tons of instructions, some instructions, and then we have a level 2. It is also certain instruction. Okay, some instruction. Now this one, what is the difference between branch on greater than equal 0 and branch on greater than equal 0 and link? So and link, what it does, it basically note down the address of the next instruction from this point, which is now next instruction is this, which is at level 1. Okay, so note that address of this guy into something called R31, or it is also equivalent to write is called RT, return register, RT, I believe so. So this one is content. So at this point, okay, so at this point, before the jump to level 2, this RT content of the RT is changed to the address of level 1. Okay, now what is the significance of that, which is not given here? We'll learn that a little bit later. It's called, there is an instruction called jump on register. Okay, so jump register, so it is in generic, like I can put any register there, so it will jump to a location defined by the content of this register. Now replace that with RT. So here, assuming RT is not changed anywhere in between these instructions after the level 2, so in this whole situation, what it will do, it will, let's say, test, okay, test these registers, and to be in the test condition met, it jumped to the level 2, but also noted the address of the next instruction to be executed after this statement BGEZAL. Okay, so it is the address of the level 1. So it start doing at the level 2 and let's say it hits this one, jump register $RT, where the control will go back or go forward, right? Go back or go forward depends on the content of the RT, and we all know this RT already has an address of the level 1. So from here it will jump back to the next instruction to the BGEZAL. Okay, we'll see later. This mechanism is actually used to implement procedural call in assembly language. Okay, so it calls for a procedure from one point, then use the address, return address, okay, or maybe it is RA. We'll check what is that address register name is, but it is 31. Okay, RT or RA, I forgot. Return address, maybe the return address is the right name there. Okay, so it uses as a return address, okay, that register 31, and it stores that from the call point of the procedure, and procedure gets execute and then jump back to the next instruction to the procedure call. Okay, so this guy is very interesting concept of jump and linking. All right. Now we have like similarly branch on greater than 0, branch on less than equal 0. We have branch on less than and link. So link we already described. What is the link? Branch on less than 0 is here. Branch on not equal is there. Now we have couple of pseudo instruction too. Branch on equal 0, branch on greater than equal, branch on greater than equal unsigned, branch on greater than, branch on greater than unsigned, stuff like that. We have branch on less than equal. So whatever you feel or you need, it's either there as a pseudo instruction or as a native instruction supported by the processor. We have branch on less than that we have used earlier on this in our example. Branch on less than unsigned, which is pseudo instruction. Branch on not equal 0, etc. Okay. Now, so basically all these branch instructions. So what you need to understand is all of them actually wants to either do a procedural call, okay, do a procedural call support with a link, and they are mainly used for implementing if then else block or loop. Okay, so any loop you can think of, like for loop, while loop, repeat until loop, can be broken down into this kind of part, like some block of instruction, some testing, go back and repeat that block, anything. Okay, think of that situation. And also you can do all this if then else block with the forward jumping. All right, the last set of instruction we'll review in this section is the jump instruction. Jump instruction, we have like a direct jump, like unconditional jump to the instruction at the target, and all the instructions can be like the jump will be encoded with the 26-bit of addressing. So this practically means we are practically can jump from one location back and forth with respect to like not this is not a relative jumping, but we can encode like how do you say 26-bit, right? So 26-bit, which can give you like 32 meg instruction. Okay, so all the levels, when it scans through, it got an address with respect to the start of the program, right? And as long as it is within 32 meg instruction limit, 32 meg instruction limit, which is quite a lot by the way, this jump can work. Okay. If it is more than that, question becomes, it is more than that, compiler and assembler actually kind of try to break it down into several components under 32 meg and try to do address translation with respect to that. Sometimes it deploys that technique of the PC relative addressing. For example, like this one, let's say a PC contains like an upper 6-bit, right? Let's say this, will call it U, and then we have rest 26-bit of lower bit position on the address, and the instruction itself has a 6-bit of opcode and 26-bit of address. Remember this addressing mode, then the next target address becomes like this U from the PC, upper bit from the PC, and this 26-bit from the instruction itself, something like that. So it tries to kind of manage if your program is more than 32 meg by splitting, slicing, dicing the problem, and also trying to employ some more sophisticated scheme of constructing the address supported in this processor. But in our class, most of our program won't even reach that big size, so don't worry about that right now how it goes. So it just take for right now, take as a granted that this guy will just jump for the 26-bit address. Okay, prepended with 6-bit of zeros. Okay, jump and link. So jump concept we have already seen, and link concept also we have seen in this branch and link somewhere in the last section, right? So link is the same thing. So you jump to the target, but note the return address, note the next instruction to the JL, the address of the next instruction in some register called RA. Okay, so that inside wherever we are target jumping, after that when we execute the end of that, we can put a $RA to come back to this jump location after this jump location. So this is exactly is used in implementing the procedure call in assembly language. Okay, so by default, jump and link put the return address into the register array, but we can have something like jump and link RSRD, jump and link register, which means unconditionally jump to the instruction whose address is in register RS. Okay, so we are not bounding ourselves to the 26-bit of target. Okay, 26-bit of address, but what we're doing is this, like, okay, go and jump to that whatever 32-bit address produced or kept in this RS register, and the address of the next instruction, put that in the RT. Okay, so that means with these we are not bound by a 26-bit of jump address locations, but we can actually avail all 32-bit memory space available to us from jumping to and fro. And we have the jump register to jump on the register whatever the content of this, and most popular or most frequent usage of this instruction is the return from a procedure, which is JR $RA, which is commonly used. Okay, rest of this instruction is a trap instructions, which are mainly for handling the interrupt. So we'll probably discuss a little bit on that when we come back to that very topic of this interrupt implementation and interrupt programming in assembly.